Rick, thanks for coming up today. You're on.
Well, that's it. Okay, boom, done. Hi, everybody. My name is Rick Galinson. I'm a longtime friend of Parallax and user of your products, and happy to be here. And just wanted to say the first thing out when I do speak here is that you will learn nothing from me during this. And like the other people who come up here have incredible projects and are brilliant people, and they've done things that you can use in the future and stuff. But I'm just showing you things that I've used their products on. Starting with the basic stamps is when I first learned about Parallax years and years ago. But a little bit about me first. I'm going to just start this thing here. This is just some background slides of some of the shows I've worked on in the past, and several of them I've used Parallax products like the basic stamps and propeller chips. So we're seeing like a lot of the Star Wars shows on Disney right now. I've done a lot of the creatures and droids for those. Skeleton Crew, we did Alien Romulus and the new Superman movie, which they have a robot in there that we built at Legacy Effects, and I built the head mechanism, and it's got a propeller chip in there that's running all the lights in the eyes, and it's using a radio control, and it's the interface I do. So from a distance, I can change the colors of the lights and turn on sequences from the radio. So this just keeps on going through here, and then you're going to see some pictures of some things I've used them on. But the first project that I really used the propeller chip on was this paintball gun. So this is something I brought up here a couple of years ago. I think it was maybe 13 years ago. And we went out back with it, and propeller chips in here, designed around existing paintball guns that are very cylindrical and linear, so they're easy to, oh wait, there it is. That's the first time I used a Parallax product. That's a basic stamp too. And it was for a game show company that was promoting the new Family Feud network show. And they wanted a podium at the conventions where 3 contestants could come up from the crowd and play and hit the buzzer and win and all that. So I got called by somebody to say, can you do this? I said, I don't know. I've always wanted to learn microcontrollers, and I've heard about this basic stamp thing. So I went down, said, give me a couple hours. I went down to an electronics store, All Electronics, which is no longer there, sadly, and picked up a starter kit and went back, read it, and hooked it up and was able to do the job. So that was off to the races with me. And then from that point on, I just kept using it in every job we did. Spider-Man 2, we did Dr. Octopus's tentacles, and he had the spines in his back, and his little fingers would come out and grab things. We used those to control all kinds of stuff. And on that show, there's some pictures a little bit later in here. Hopefully I started it up. Go. It's not going. We use a touchscreen controller to control the fingers of Dr. Octopus's tentacles. And then I ended up taking that and building this controller I made for my submarine, which is on the desk over there by the sub. You can come by and see it later, but there's a touchscreen on top, and the data from the touchscreen goes into a basic stamp, and then from there through the radio system to the character, and would allow us to do these really complex finger moves with servos that you couldn't do by puppeteering live. There were just too many controls to control a hand. So hand has basically like 15 to 17 moves in it. And for somebody to operate those individually would be very, very difficult. And there was a crazy mechanical hand that had to fold up inside of itself. And it was just impossible for a human. So they were about to give up on it. And I said, well, with one of these chips, I could program keyframes and say the fingers are here to here to here to here to here. And that would go super fast and precise every time. You just needed to trigger the event. So in one case, you would be puppeteering it live with a radio control and a few channels running the whole thing like this. Then you'd hit a switch. It would take over from you, make the fingers safe so they wouldn't collide with each other. And they would either flick them around into a triangular pose or up like a piano hand that he could like be the evil mad scientist. Why is this not playing? This is upsetting me. Let's see. Yeah, I think I have a lot of, there it is. All right, there's another good one. So on one of the biggest films I ever did was Jurassic Park. It had no electronics in it whatsoever. Sorry, Ken, but that was where I kind of got my start. Within a year of starting in the industry, I got to build the spitter dinosaur on the original Jurassic, and that's a skinny, young version of me who has good eyesight. And ever since then, it's been fun. Every job is different. And so for the new Superman coming up in August, I think it's in August or July, This is the robot that we built at Legacy Effects. And so the head there has a bunch of these NeoPixel LEDs in there. We're using a propeller chip. And of course, as always, shout out to John. His software to drive LEDs is amazing, and I use them in every project I do. And I always take him out to dinner to say thank you. And he's so generous of giving that to everybody. Yeah. And every time I do a job and I need some new tech that I'm using for that job, I always go to him, and he writes me some good driver code, and then I butcher it and put it up. So let's see. What? That one? Why is this not? Sorry about this. I don't know why it's stopping right there. I'll just let it run. This is a thing called the Black Badge. It was for DEF CON. If anybody's familiar with DEF CON, the biggest hacker conference in the world in Las Vegas. And John introduced me to some of the people who ran it. We went there and we got the nod to build the Black Badges, which are kind of like the Oscar for the hackers. And so we made 24 of these in a crazy rush session, stuck in a hotel room for like 3 days with like 6 of us just trying to finish these things. But they had they had 3 servos in them. They had NeoPixels for the lights that would blink. And if I'm not mistaken, John, you wrote the code for these, right? Yeah. So it's kind of a randomizer for the motion of the eye tentacle. So that eyeball would come out of that white plastic piece and then move around. A little tentacle mechanism I came up with years ago, and it's all 3D printed. And this is just a front version of it here. But it would come out and look around and then retract back into the head. So the theme was Rise of the Robots and Rise of the Machines, I believe. And we got to make these. And one of them ended up, we gave it to the guy who runs DEF CON. And their competition for the Black Badge was taking these supercomputers, and they had put like 7 or 8 of them in a group. And the companies or the engineer groups, what would you call them?
It was a DARPA challenge.
It was a DARPA challenge. Yeah, so these computers all sat in their own network, fighting each other, trying to get in access and screw each other up while defending against these like AI-driven code, whatever they wrote. And the ones who won that competition got this $2 million grant, and they got the prestige of being the winners, and they got the badges. And then the guy who ran the thing, we gave him one of the badges as an honorary thing, and he hung it on the supercomputer that won, and it ended up going to the Smithsonian. So one of these things that we built ended up in the Smithsonian, which is kind of cool. I thought that was a nice little added feature. So this is some of the laser cutting we did in my house for all the back plates. And then this is one of my boards I made years ago. Again, learning tons from John and how to do circuit boards correctly. And I'm just gonna let this run through. Oh, here's some cool things from a video game I did for Destiny 2. We did all these light reference weapons. And so we make these, people made the costumes, and then they have these weapons. The sword has flames on it. The shield is an electrical generator kind of thing. And then in the background, there's a staff on the girl in the back, you'll see in a second, that's got like weird purple electricity going across it. But in the video game, when they do the commercial, they shoot the take a whole bunch of times, and then they have to do the post-op special effects on it. They have to add all the fire elements, add all the lightning bolts and stuff, but they don't want to do it for every take. So they pick the best one, and then they add the fire to that one. But they got to put flame, shadows, and lights on the leather and the metal reflective surfaces, the helmet and the buckles, and then the fog in the air, and anything walking by would get reflection of light. So they have to have something that looks right. And so they asked me to do the design of all the weapons and the software for these things. So they come in. And the next clip is going to be a close-up of this guy's flaming sword. And if you imagine, just kind of cover up the sword, but see the lights on his helmet, it really does look like there's flames kind of on there. So all they have to do is cover up that silly plastic sword or that shield, and they put their effects on that, and they're done. All the leather work and the plastic work all looks like there's flame next to it. So it makes it really easy. And this is another character for that video game, Cade 6. And this was the first 3D printed head I ever did. So this was printed on a really high-tech printer about 15, maybe 20 years ago. And it's all animated. So I'm puppeteering all this. And again, a propeller chip was running the lights in the eyes and the lights in the back, illuminating the inside of the head, giving it some depth. And I had put a program in where it would just it would blink every like 4 or 5 seconds, and I don't think it's in this shot here, but something like 15 servos running in this thing. So I would puppeteer it and make it speak and do the lines over the loudspeaker while we were actually shooting the commercial. So that was a pretty good one. I know this is all just 3D printed plastic and that's made to look metal. These are some Pac-Man ghost costumes I did, again, with a propeller chip. There's probably 4,000 NeoPixel LEDs in each one of these. Running off a couple 12-volt batteries. This is my backyard, and I'm getting the kids, my daughter's in the blue one, and a couple other friends. I said, how fast can you run around in these things? They have a little like tank visor slit so they can see where they're going. And that was for this billionaire in Florida wanted to do. We did a commercial for Pac-Man for Bud Light years ago for the Super Bowl, and it played once, and it was a really big hit. But it was a full-size Pac-Man maze, and they did it downtown LA. And then this guy in Florida wanted to do a party for his friends, and had to do a smaller version. So I had to start from scratch and just rebuild these things a much smaller scale because they wouldn't fit. Like the original ones wouldn't fit in the maze they were talking about, and the original ones were thrown away and recycled years ago. So we did those, and that was a big hit. And now I'm making another one of those ghosts today. Actually, it's in my house right now, like almost ready to be turned on. And so now here we get to some machinery work. So in my job, I'm going to show you at the very end, kind of like what happens in the day of the life of a special effects guy like me at doing animatronics. There was a guy I worked with a long time ago who kind of made fun of somebody for not having like one really good skill set. Like, you're not a master of one, and I'm like, no, I'm like, jack of all trades, master of none. And I'm kind of proud of that because it gets me to be able to build this on my own without anybody's help. I'm not going to call John to do the circuit board and you to do the programming and you do the machining and laser cutting design, but it would take forever to coordinate all my friends to do that. So I learned all these skills to a decent point where I can do them and get the job done. And it's not going to be as pretty as if, you did this and you did this, all those parts, but it's fun. So I'll show you that kind of like workflow. Typically now we do for like making a creature head. So this is just some of the machinery work that went into some of the pieces in here before 3D printing was around. And so I had to build all this stuff, machine it all myself in my garage, design it all. And there's a couple of them on my Jeep. And this is the hopper on the side, holds 1,000 rounds. There's a bunch of different prototypes in my mill back there. And a crazy get up for a TV show. This is on Jurassic Park. These are the spitter heads. And this is another movie, an Alien versus Predator movie. No, The Thing. This was AI, Mighty Joe Young. Another one from Mighty Joe Young in the Jungles. So what's fun about my job is some days we build a giant gorilla like this that's huge and hydraulic and massive. And then the next week I'm building a watch. So doing tiny little things. And the next week I'm doing LEDs, just doing software. So it varies. So every day is a different job for me, which keeps it exciting. This is a plastic model I made for a Sooner, which is an aerospace supply company. They wanted something to display up here at one of the expos, showing how and then I made this engine for them, showing that those curved metal pieces is what they sell. This is part of Doc Ock. This is part of his tentacle. This is his back plate that he wears. And these are the little fingers that I was talking about earlier that deploy. Here it is being used. So they start out all compact inside of each other. A friend of mine named Khan designed the fingers themselves, and I did from the base knuckle back with all the other mechanisms in the software. So you see how it kind of changes and moves out. So like the two bottom fingers, normally it's like a triangular fit, and then it can go up to like a piano hand. We call that because he was going to like playing the piano with his robotic arms and his hands. And then to get them to go back to the round thing, a human couldn't do this because the fingers could collide when they swung in. So the computer takes over and straightens them out. Oh, you got cut off before you saw all of it. Anyway, so more circuit boards I've designed over the years. That's the minigun first one here with the propeller chip, bunch of basic stamp 2 boards for something else. And I think we're getting really close to the end here. And another thing we did with the propeller chip was really fun. We shot this down in Argentina in the winter. We had 6 snowboarders, and they were covered in LEDs. And we could remote control the colors of the snowboarders with a radio control. So red, green, and blue off 3 different sticks. And so they're snowboarding down these mountains in the middle of the night, and it's pitch black out there. And the only light out there is their own suit illuminating the air in front of them. And you're just kind of red, blue, green, mixing the colors. And all of a sudden, once in a while, all my sticks would go to 0, and the guy would disappear on the hill. And you could kind of hear him scream, like, turn the lights on, because And you'll see in a second, at one point they were skiing down in the big open areas. It's not a big deal, but in the trees they were going through, it was really, really kind of terrifying. So this is one of the guys waiting to go down the hill. This is them going through the trees. And when the lights go off on one, that's not good. But so, and here's the Super Bowl commercial, a quick shot from that. And then, okay, so here is the day in the life of building a creature. And what I wanted to do was bring my scanner up and scan Ken and do this last night and show you Ken being turned into a puppet. But here we go. So we start with CAD. So we have a CAD program, and I'm just going to draw a quick pulley right here and a little pivot that holds it. This might make like an eyeball move or a tongue or a mouth or something. So you just start with simple shapes. I'm sure a lot of you are very familiar with CAD. This is going to be boring, but so you just start with simple shapes. What software? This one's called, it's Ashler Vellum makes this. It's called Cobalt. It's a 3D one. It's ancient history. This is a really old program. A lot of us use Fusion 360 now. That's a really popular one at the shop, but I'm so much faster with this one that I don't use Fusion. I can, and I've designed stuff, but the jobs we have to do are so fast that I don't have time to learn on the job anymore. I got to go. So this would be an example of just making a simple pulley, replicating parts, then making the 3D models, and then we 3D print almost everything now. So all the creatures we do, all the mechanisms that hold the servos, all the pulleys, all the mechanisms like for the jaw and the eyes, those are all 3D printed. And then we have model shop people come in and like smooth them out, get them to where they're glass clean and paint them, and we make molds and replicas. So there's making a simple pulley. And then that would pop into, then I added another piece of that for a second. Where is it? I didn't edit that video very well. So if anybody has any questions while the boring part's happening, fire them out, please, about any of this stuff. I'm going to zoom through this a little bit more. Okay, so then this is the fun part. There's a program called ZBrush, which is kind of an artistic digital sculpting program. And this is a scan off of a raptor from like a Jurassic Park movie. So if I get a creature like a raptor and they want to make an animatronic, they'll give this sculpt to me, the digital sculpt. And this is kind of showing what you can do with this program. So when you bring in the model, it's made out of polygons, creating the texture. You can smooth it out, you can stretch it, you can add thickness to it. So I'm going to show you a couple of tools. There's about 1,000 tools and 1,000 variants of all those tools. So you can just grab the skin and pull it and inflate it and push depressions in it. You can create little scars and valleys. You can add musculature. So if you want to give it a bigger like jawline, you do this and then you smooth it out, and it's just that fast. If you don't like it, you hit undo and it pops away like that. And then, so what I did on this one here, I'm going to give it a little bit more like a bigger neck. Okay, so now I take this head and I chop off the parts I don't need, and then you create a cavity to get the skin thickness that you're going to want. So whether it's a silicone skin or a foam latex skin, it stretches and moves differently. So you got to really know what areas. And then you go in with an X-ray block up on the side. There's a red brick or box right there, X-ray. And I would take that and would kind of put it through the character. And you could see how thick the skin is in any one place. And you can go and push and pull and make the skin thicker where you need to and thinner where it's important. So then you boolean out the eyes, you boolean out the jaw, you put a pivot there where the jaw would pivot. And you can actually test the jaw. Let's see. There it is. So now I get this pivot point that I've kind of taken a guess at, and do I want this jaw to pivot there? What's it going to look like? So then I move it, and you always end up with the lips touching in the right place. And you can move that pivot up further into the head and then do another motion study and see if that's a better place. And then once you get these things kind of isolated and figured out, then you can go and start taking the motor designs. And here's the X-ray they use. You cut through it. And then you can move that rectangular block through the part, and you can see a cross section. I color it red, so it's really easy to see what's going on, and that's one way to look at it. And then I come down here, and this would be like the mechanical side on the inside part. So you have like a skull here that we have, and the pink part is the edge of the skin, the green skin, and then you have the red parts, the edge of the core, the skull. And then all that white stuff back there will be all the motors to make it move. And there'll be eyelids that get glued down with the skin, so they can make the eyes move around, and the eyelids can open and close, and maybe you put a tongue in there, but that would be like a 3-axis neck for a head nod, pitch, and roll. Yeah.
How long would it take you to design something like that?
Like in the real world?
Yeah.
Probably a couple weeks. Yeah, 2-3 weeks to get it all really figured out. I mean, there's a lot to it, because a lot of times, like this raptor head's pretty big, and your 3D printers aren't. So to get that entire skull as one shot on a 3D printer is very unlikely. We use these HP powder printers, the inkjet printers, and they're phenomenal, but there's a build volume, and I have a tool that's in here, and I can pull it in, this rectangle, which is my build volume. And I'll put that over this and make it like a transparency, and I'll see, okay, can I get it in there? No, I can't get it in one shot. All right, now I've got to break it into 2, 3, 4 pieces, and figure out, and then I have to add all these tabs to go between the 2 pieces and put the screws, the Boolean holes, so that all the screws are there, so it screws together like a model kit. So all these things you trip on, you're like, oh, now I need like 3 more hours to do all this work to make sure, and then you have to make sure you have clearances, and then when I'm trying to get things on the printer, everybody else is trying to print things too on the other 4 jobs that we're doing. So it gets really crowded, and then that can slow you down too. But somehow we always get it done on time and out the door. Yeah, so that's kind of it. Yes. Oh. MJF. Yeah, it's the HP. It's the MJF. Yes. Yeah, the multi-jet fusion. Yeah, it's a really great material. It gives us all the plastic comes out. It's got a coating of white on it, but it's a nylon, and it holds a thread really well. So if you tapped it for a screw to go into it, it will hold it, but it's flexible and really strong. So it's an amazing machine. But, yeah. All right. So for this camera here. Okay. No, we're not going to make any noise, but. So you can go really slow, tap it, or go fast, variable speed. And this hopper here holds 1,000 rounds. Pull this back against the spring tension, load 1,000 rounds in there, and the springs will pull that forward all the way, forcing the paint in. So you could shoot straight up and down or upside down if you had to. This 1,000 round hopper will go in 18 seconds at full speed. So they shoot 60 a second. So in 1 minute, that's 3,600 rounds you shot down range. And it shoots pepper balls too. So I'm available for embassy protection and non-lethal deterrence to anybody out there who wants to. So yeah, this again was a project of passion, just like the submarine. And I see a lot of us when we build these things and come to stuff, we start with a project like that and hope maybe it goes to market, maybe it doesn't, but it's just fun to figure out, what are the problems that this is going to create? How do I get around it? And it keeps your brain fresh and just kind of gives you a purpose. But lately I haven't had a lot of time. So yes. Who what? Did what? Came to Parallax first? John used to work here. He's been here forever. 1994, yeah. I'm not sure the year of that that Family Feud thing, but that was the first time I'd seen the ads, and I was kind of intimidated by it because I don't know how to do this stuff. It's crazy. And then I said, well, I got a job opportunity. Maybe let's see if I can do it. And the literature you guys had and the support you had was great, and it made it really simple to just start off and doing DTMF and reading button presses and creating sounds and turning on lights. It was great. So very easy to use. And, I push you guys every day on people, like, use propeller stuff. It's great. Yeah. So, yeah.
I heard you explaining yesterday how those things counter rotate. Explain that about how the paintball moves from
into here. So Chip's asking me to explain how the loading mechanism works that I have a patent on. I don't want to tell anybody. No. So basically, the trick with this was I used to play paintball a long time ago, and then my roommate and I were watching Predator. And at one point in Predator, the guys got the minigun and they just completely decimate a forest with it. And we looked at each other like, wouldn't that be fun in paintball? You know, like, yeah, I'm like, well, it's impossible because paintballs are made to break. They're super fragile. How are you going to get it across something? How do you get a paintball into that while it's spinning without cutting it in half and causing paint everywhere? And so that was the trick. And so I figured out a way that this loading mechanism is exactly the diameter as the gun itself. And there's 6 barrels. Each one has a hole, like a breech for the paintball to go into. And these lighter colored gears mesh in there. And on this side, there's a disc inside here. And there's 6 holes, equally spaced. And because you can line them up with these gears, there's one hole on the loader on this side, you know, that's going around. And then there's a paintball gun here. And they're coming up together and they're meeting just briefly in the middle, going around. But there's 6 of those. So they're all meeting as they go by. So they're timed with the gears. And this outside rim here of this is kind of like a wall that keeps the paintballs from just shooting out. If this wasn't here and you turned it on, all the paintballs in here would just start scattering, being thrown out. But the wall keeps them intact, and they're kind of waiting in their turn to get around to where there's no wall, and then they just gotta get, you know, thrown out. So it's centripetal force. Yeah, it's always wanting to push them outwards. So it's wanting to push it outwards, but it can't do it until it gets right to the middle of the gun. And that's when the barrel happens to come around with its little receiver, and the ball shoots right across into that little gap and just goes about an inch. And it's moving exactly the same speed as the gun is moving and the feeder is going. So there's nothing around the paintballs that's really moving super fast relative to the paintball. So it's not going to encounter something that might shear it or break it. So it just jumps across this little gap. And then there's another piece up here that acts like the wall that covers up that hole immediately and keeps it in there. And by that time, it's already firing the air blast to shoot the paintballs out. So that was the fix. Yes?
How many paintballs did you break before you came up with the design?
I broke a lot after I came up with the design. No, it's, yeah, just figuring out what to do.
Was it intuitive? It's like, oh, it's just
Yeah.
like you would have gone through.
I have a couple of different hopper designs, like the feeding mechanisms. And then, yeah, I had one that was with brushes that was trying to just push the paintballs really fast with light brush force, you know, and that wasn't working. And so I was just going through a few different iterations, but I have plenty of paint. I have plenty of paint on my hands over the years. And, you know, yeah.
Rick, what were you doing as a kid? Like high school?
As a kid,
your influences leading into all this.
I was a big Lego kid. You know, when I was like 10 years old, Star Wars came out, blew my mind. It was just such a creative experience to watch that and let your brain go. And I got the books on how they did it. And Lego came out with mechanical Lego around that time. They had gears and motors and little car chassis. That was just like, wow, what's it? Yeah, it was amazing. Just like, that's how a gear worked. What, you know? And we take it for granted now because we see it every day and we've known about them. But at some point, you get inspired as a kid. You're like, wow, that blew my mind. And as far as parallax is concerned with me, the programming of microcontroller is to affect the world with typing, making something move because you typed. I had a moment like that when I was, I think, graduated high school, and I saw the movie Aliens. The first movie scared me to death, and I learned how to do special effects because I studied how they made the creature costume and the sets were amazing and how the depth of detail they went to. But the second movie, Aliens, at one point, Lance Henriksen's character, the robot Bishop, is crawling through, and he's got to get the spaceship to come down from outer space and land on the planet. So he brings his computer and he taps into the big radar antenna, and he starts typing. He looks up, and the thing starts moving because he typed. I'm like, wait, you can type something and then a motor moves? And how do you do? That was my moment. Just like, I want to learn how to do that. And it took a few years to get to the point where I was in front of something like a basic SAMP kit, you know, where I was like, I don't know where to go to learn this. And there was no internet back then, so it was much more difficult to progress. You know, you had to get lucky and land on the right spot. So
Not educational, motivated. Like, did you go to college?
yeah, I went to USC. I got a degree in biomedical engineering. which covered biochemistry, all mechanics, aerospace, not really civil engineering, but like tons of biology, organic chemistry, everything. It was a computer science, electrical engineering. It was everything to a point, kind of like what I said earlier about jack of all trades, master of none. I would be really good at a really big company and be able to talk to electrical engineers and the biochemists and the geneticists. And I know I speak your language, I've done your things, but I wouldn't be able to do your job or your job really. But I could be the go-between really, really effectively. So that's what biomedical was. It was predominantly like a pre-med major. A lot of my friends went on to be doctors, but I was like, I'm done. I want to go make puppets. No, I never actually said that. I just, figured my parents were just like, no. Yeah. So that's it. Ta-da! I have a million other pictures and videos. A lot of them I can't show people because the shows haven't come out yet. That's a big NDA thing where you're not allowed to talk about it. So, yeah. So if you have any questions or whatever, stop by, say hi, or shoot them out now. So, yeah. Oh, thank you.